Hello students, the question says, the marks of candidates in mathematics and English in 2009 is represented by the random variables x and y. The distributions are normal, so these are the parameters given. Respectively, candidates' marks were combined to give a final mark f. So f is a function of x plus half y. So in that case, first we have to find the expected value of f, which is same as mean of f. So in that case, if we apply the formula, so that gives us the expected value of x plus half the expected value of y. As we know that expected value is nothing but the mean of it. So expected value of x, so it's 28 plus half of expected value of y, which is 52. So we cancel this, this is 26. So the expected value of f is 54. Similarly, we need to calculate the variance of f. So the formula for the variance of f will be variance of x plus 1 by 4 variance of y. So the formula that we have used over here, that if we are finding the variance of ax, so that becomes a squared variance of x. So similarly, if I'm finding variance of half y, so the value of a is half. So a square means 1 by 4 into variance of y. So the variance of x is 5.6 whole square plus 1 by 4, and the variance of y is 12.4 whole square. So the variance that we got for this is 69.8. So that's the variance of f. Now moving ahead, it says that the final marks of a random sample of 10 candidates from Grinford in 2009 had a mean of 49. Test at 5% level of significance whether the results suggest that the mean mark of all candidates from Grinford was lower than elsewhere. Now see here, it's lower than, so it will be a one-tailed test. Now, we first have to calculate the test static z. For that, we need to write the null hypothesis. That means that Grinford mean, if I'm writing for the null hypothesis, please pay attention. So it should be Grinford mean is equal to the value that we have calculated for the expected value of f, which is equals to 54. And for the alternate hypothesis, we'll write that Grinford mean, since it's a one-tailed test, so has to be less than 54. So please remember it's less than 54, so it's a one-tailed test. Now, for this, we need to calculate the z static for this. So the formula for this is mean, which is given over here, which is 49, minus the calculated mean that we have calculated is 54, divided by root under standard deviation. So we have to find standard deviation. The variance of f is known. So that is root under variance. That gives us the SD. And divided by root under the sample size. Since we have taken it for the 10 candidates, so the sample size is 10. So that is root under 10. So the formula that we used over here is the sample mean minus the population mean that we have calculated by standard deviation by root under sample size. So the z test static that we got from here is equals to minus 1.89. We can allow 3, or we can even approximate as minus 1.892 as well. So these two values. Now, we have to check at 5% significance level, and we know that at 5% significance level with one-tail test, the z value has to be minus 1.645 if we are comparing it with the negative z test static of 0.892, since it is lying outside the critical region. So evidence that Greenfield mean is lower, that means alternate hypothesis is accepted. That means H1 is accepted. That's because the test static that we calculated is lying outside the critical region for 5% level of significance, which is equals to minus 1.645. And that will be the answer for this particular question. Thank you, students.